So in lecture 1, continuing, completing the square, a different type of example. So here I have negative 2x squared plus 3x is equal to negative 5. So in the previous completing the square example, I left the plus, the negative 5, or the constant rather, on the right-hand side. As I said, in some exam questions, you may see this constant on the left side. So let's do that and see what happens. So this is minus 2x squared plus 3x plus 5 is equal to 0. The next very significant difference to the previous example is that the coefficient of x squared this time is not positive 1, it's negative 2. So it's very important to identify that and to change the coefficient to positive 1 each time. So the way we do that is we will simply factorize out the coefficient of the x squared term. So that will be negative 2 into x squared minus 3 over 2x minus 5 over 2, close the bracket, equals 0. Expand into the bracket to check if all the terms are correct. So negative 2 times x squared, negative 2 times negative 3 over 2x is indeed positive 3x. Negative 2 times negative 5 over 2 is indeed positive 5. So once again, if you look within the square bracket, the coefficient of the x term is what we target in completing the square. It's this coefficient that we halve. We will square that, and then we'll add that to the left and subtract that on the left. So adding and subtracting the same quantity on the left means that the equation's value has not changed. The equation is in balance. So that's a desirable outcome. So let's put all of that down so it's not so abstract. Just before I get ahead, note that negative 2 is factorized out. So I am permitted to divide minus 2 on the left as long as I divide minus 2 on the right. Now, this would only work if you've got a 0 on the right side, or in other circumstances as well. If it's not a 0, you'd have to ensure that it does become a 0. So the negative 2 cross cancels on the left. And so we have x squared minus 3 over 2 x squared minus 3 over 2x. As I said, we're going to add half the coefficient of the x term squared on the left. And we are going to subtract it as well. So we're going to add, so let's put in the addition sign here. Half of minus 3 over 2 is minus 3 over 4, which we will now square. And we'll subtract that on the left as well. Right, so we added and subtracted the same quantity. Don't forget the negative 5 over 2. And that's equal to 0 indeed. The right-hand side is 0. Now, once again, notice the x is squared and the negative 3 over 4 is squared. That provides the ready-made factorization for the first 3 terms on the left side. So that's x squared, or minus 3 over 2x plus, open brackets, negative 3 over 4, close brackets, all squared. The first 3 terms are factorized to give us x minus 3 over 4 all squared. With the last 2 terms, terms numbers 4 and 5 here, be very careful with the signs. There's a negative, and negative 3 all squared is 9, and 4 squared is 16. Minus 5 over 2 equals 0. So we'll move the constants to the right side and leave the variable term on the left. So this will simply be 9 over 16 plus 5 over 2. But 5 over 2 with an LCD of 16 will give us 8 to 16 for the denominator, and 8 times 5 is 40 for the numerator, and that's simply 49 over 16. I'm just correcting the number to ensure it's 49 over 16. Right. So now, as we saw when we have a squared quantity on the left and right, we square root the left and we square root the right. The right side would get a plus or minus sign when we square root. So that will simply give us x minus 3 over 4 on the left is equal to plus or minus. The square root of 49 is 7, and the square root of 16 is 4. So our two answers would be x equals 3 over 4 plus 7 over 4, which would be 10 over 4, and that would be 2.5 or 2.5. 2 4s are 8, remainder 2s out of 4, so that's 2.5, or x would be 3 over 4 minus 7 over 4. So 3 minus 7 is negative 4. Divided by 4 will give you negative 1. And that completes that example, which went really well, barring the little hiccup on the recording side, I believe. Now let's look at the K method. Okay, so this method I'll explain to you when it becomes very clear that you must indeed use this method. First, let me put the example down on the board, which I want to subdivide here. So here we go. I've got the example 3x raised to 2/3 minus 7x raised to 1/3 add 2 equals 0. Now, when you see a base and an exponent related, so you've got x to the 1/3, x to the 2/3, they're related because x to the 1/3 times x to the 1/3 will actually give us x to the 2/3, right? Now, at your senior level of mathematics, you'd understand how this works. Like bases being multiplied, you add your exponents. So what we're going to do in the K method is let K equals x raised to 1/3. So to get to x to the 2/3, we've got to multiply x to the 1/3 by x to the 1/3. But x to the 1/3 is k. So it's k times k, and that would give you k squared. So now we'd simply get 3k squared minus 7k plus 2 equals 0. So all we've done is replaced x to the 1/3 with a k and x to the 2/3 with k squared. All right, now we're going to factorize. So that will give us 3k in the first bracket times k in the second bracket. That will indeed give us 3k times k is 3k squared. Now we're looking for a plus 2. And noticing we've got a negative 7 as a middle term. So plus 2 can be obtained by multiplying minus 2 and minus 1. Minus 2 times minus 1 is plus 2. And the middle term, negative 2k, negative 3k, that's negative 5k. So that fails. I'm glad that happened, and that shows you what you'd need to do in an exam. So it looks very clear that the negative 2 needed to be in the second bracket and the negative 1 in the first bracket. So 3k times k is 3k squared, negative 1 times negative 2 is positive 2, negative 1k and negative 6k. So that gives us negative 7k. So fantastic. We check our work as we are producing answers, right? So the first bracket will be equal to 0, 3k minus 1 equals 0, or k minus 2 will be equal to 0. Solve this, so 3k would be equals 1, giving us k equals 1 over 3, or k equals 2. Now remember, the examiner has given us a variable which is x. So we need to solve for x and not just k. So we've got the k values, but we know k is x raised to 1/3. So x raised to 1/3 is equal to 1 over 3, or x raised to 1/3 is equal to 2. Now, the easiest way to get rid of an exponent of 1/3 is simply to cube the left, but if you do that on the left, do that on the right. So we're going to cube the left. And notice whenever I cube a quantity or square root a quantity in my lectures, I would most often, if not always, bracket the quantity. Okay, so that tells us that x is equal to 1/3 all cubed, which is 1 over 27, or x is equal to 2 cubed, which is 8. Those are our two answers, which I can sign out by simply underlining them. I'm happy with those. Now, it's a little bit of a long lecture, but bear with me. I just want to give you another example using the K method. So here we go. Subdivide the page. All right, and I've picked out another example which has its own complication. D is K method and E is K method with a different type of question. So this is 3 raised to 2x plus 1 plus 4 times 3 raised to 2x, and that is equal to 21, right? So once again, notice that your 3 raised to 2x seems to be the common factor here, talking about which perhaps one could have used factorization immediately, but for simplifying it, when you initially learning mathematics, you'd want to maybe use a substitution, which we're calling the K method. So let's split the base here. So this will be 3 raised to 2x times 3 raised to 1 plus 4 times 3 raised to 2x equals 21. And notice the 3 raised to 2x quite prominent as a common factor. So I'll let k equals 3 raised to 2x, and I'll replace 3 raised to 2x in the latter equation with k. So I'll get 3k plus 4k equals 21. Okay, 3k plus 4k equals 21. So that's 7k equals 21. Divide both sides by 7, and that tells us that k equals 3. But we don't want to solve simply for k. We want to solve for the x, which was the variable in the original equation. So k is 3 raised to 2x. So 3 raised to 2x is equal to 3. And notice we've got the same base on the left and right. The exponent understood on the right is a 1. So we drop the bases and equate the exponents. So 2x equals 1. Divide both sides by 2 to get x equals 1 over 2. And that's our final answer. So guys, thank you for that. And what we will do is continue in the next lecture with applications of quadratic and related theory, solving equations and inequalities, and we'll move to sections F, G, and H on inequalities, algebraic fractions, and simultaneous equations.